In this buoyancy problem, we have an empty balloon which has a mass of 15 grams. The balloon is filled with helium, which has a density of 0.179 kilograms per cubic meter. The filled balloon has a radius of 0.25 meters. We need to figure out what is the buoyant force acting on the balloon, what is the gravitational force of the balloon, and what is the net force acting on the balloon as well. So our balloon has two forces acting on it. The first force is the gravitational force, which is down, and the second force is the buoyant force, which is up. We expect the buoyant force to be larger because the balloon is going to rise in the air. We have the mass of the empty balloon is 15 grams. I'm going to make that conversion right now to kilograms, 0.015 kilograms. We have the density of helium, which is 0.179 kilograms per cubic meter. And we have the radius of the balloon, which is 0.25 meters. And we have the density of air, which is 1.29 kilograms per cubic meter. We need to, for part A, find the buoyant force. For part B, we need to find the gravitational force. And for part C, we need to find the net external force, or the total force acting on the balloon. The first step is to find that buoyant force. And our equation for the buoyant force is the mass of the fluid pushed out of the way times our gravitational field. Now, the fluid being pushed out of the way for our balloon, the balloon is pushing the air out of the way. So the fluid is not the helium inside, but what is being pushed or being displaced out of the way. And so I'm going to put down that it's the mass of the air being displaced. So it's always the fluid surrounding it in our buoyancy equation, the fluid surrounding it, not inside of it. So it's the mass of the air times 9.81. So how do we get the mass of the air is the question. And so we look to another equation for the mass of the air. And the mass of the air we can get through our density equation. So the density of air is equal to the mass of the air divided by the volume. Now, how much air are we talking about? We're talking about this much air. That's the amount of air being pushed out of the way. So we know the density of the air. To get the mass, we also need the volume. I'm going to approximate this shape to the volume of a sphere. And so we have that the volume of a sphere is 4/3 pi r cubed. And so we have 4/3 pi times 0.25 meters cubed. And we get our volume to be 0.065 cubic meters. Now we can get our mass of the air. So the density of air is 1.29 kilograms per cubic meter. We're solving for the mass of the air, and we know the volume to be 0.065 cubic meters. So really this density equation is density is a way to get back and forth between mass and volume for any given substance. If you know the mass or the volume of a substance, you know its density, you can find the other. We get our mass to be 0.0844 kilograms. And now we can solve for our buoyant force. And so our buoyant force is 0.0844 kilograms times 9.81 newtons per kilogram. Buoyant force acting on the balloon is 0.828 newtons. And so we solve for letter A, and that force is upward. Now to get letter B, we need to find the gravitational force. And the gravitational force is equal to the mass of not only the balloon, but there's helium inside the balloon. And that helium has gravitation as well, has weight also. And so we need to get, we have the mass of the balloon, we need the mass of the helium inside, the mass of this much helium. So again, we go to our density equation, but in this case it is the density of helium equals the mass of helium divided by the volume. So whatever density value we have, if it's for helium, the mass is for helium as well. The density is for air, the mass is for air as well. So we have the density of helium as 0.0 0.179 kilograms per cubic meter. We're getting the mass of the helium, and we know the volume. The volume of this much helium is 0.065 as well. So we get the mass of that helium, which is 0.0117 kilograms. Notice it's almost the same as the mass of the balloon itself, so it's not negligible. The balloon is 0.015 kilograms. Helium is 0.0117. So it's not something we can just ignore. And we get the gravitational force to be 0.262 newtons, and that is downward. And now we need the total force, part C. The total force is simply the sum of the two forces, the buoyant force, which is up, plus the gravitational force, which is down, so it's negative. And so we have 0.828 newtons minus 0.262 newtons. And we get the total force comes out to be 0.566 newtons. And that total is positive, and so therefore it is upward.